Good morning, everybody. Thanks for joining us this morning. We're just going to give it another minute as folks are still joining the webinar. So bear with us and we'll get started in a few. Okay, well, good morning, everybody. It's a little after 9, so I think we'll get started. My name's Mark Pignatelli. I'm with ICF. We're the vendor working on behalf of Eversource in Energize, Connecticut to bring these Passive House trainings to all of you. So thanks for joining. Looks like we have a pretty robust turnout, which is fantastic. I'm just going to touch on a couple things quick here. First off, again, thanks for joining. This is our first workshop of our 4-part building science workshop series that we have coming up. The trainings are no cost thanks to Eversource, a proud sponsor of Energize Connecticut. So really excited to be here. This training is also in partnership with Connecticut Passive House. So we've been working closely with CTPH as we continue to move forward and schedule future trainings. So just a couple reminders, we do have 3 more of these building science trainings coming up. One is actually next Friday the 19th, and then April 9th and April 16th are the final 2. So we will have a reminder slide towards the end. So definitely register for those as well. And these trainings are eligible for AIA and FIAS credits. Additionally, with this training that we're doing on behalf of Eversource Connecticut, we also are offering a 50% cost share reimbursement for professionals pursuing either FIAS or PHI accreditation trainings. So that includes the cost of the trainings, the exam, excuse me, and then once you become certified, we'll work with you to process that 50% reimbursement. So our email address is down below here on the slide. Feel free to reach out if you do have any questions. We're happy to work with you and answer any questions you may have. You will receive some follow-up emails after the workshop today that'll include a survey. So we do appreciate any feedback you can provide on your experience participating here today. So we do look forward to that valuable feedback. So with that, I will pass it over to Mike O'Donnell with Stephen Winters Associates, who will be taking over.
Thanks, Mark. Good morning, everyone. My name is Mike O'Donnell. I'm with Stephen Winter, and we'll get started here on workshop 1. So just some administrative stuff first, just kind of the format of the webinar. So essentially everyone's been placed on mute, but if you do have a question, please put it into the chat section, and we'll answer them. We'll try to take the questions at the end of each segment. There's kind of a lot of material to get through today, so we'll do our best to answer questions, and any that we don't get to, we'll follow up separately afterwards. And one additional thing is we have a couple of polls, so active polls for participation throughout the presentation. So we just ask that you either use the website pollev.com, or you can do it via text message, just to get that set up now. So when the polls come up, you can send in your answers. Katie, can you see my mouse pointer?
Yes.
Okay, cool, thank you. All right, so just a little bit about me. Again, my name is Mike O'Donnell. I've been with Stephen Winter Associates for 9 years. I'm a principal building systems consultant working on our Passive House team, and I lead a lot of the field inspections and testing and verification aspects on our passive house projects. My background is in energy management, and I started off with working on single-family homes, and actually in my previous company, actually crossed paths with Mark, so it's kind of interesting that we're back and working together again on another project here. And yeah, so that's just a little bit about me. And today's workshop is going to be Introduction to Passive House and the Building Envelope. So might be a little bit more generic, but we do have some good project photos and details, and then we'll kind of go from there. So just a quick blurb about Stephen Winter. We offer energy conservation consulting, green building certifications, and accessibility consulting. 3 offices, actually 4 now. We have a budding Boston office, New York, DC, and Connecticut. And upon completion of this, you can, we'll send out a link to the webinar, also a PDF of the presentation, FIAS's self-report. So Katie, we may need to share that information, right?
Yes, there's FIA's self-report information in the chat box.
Okay. Also, sorry, I forgot to mention that Katie Troy is also on the line. She's from Stephen Winter Associates as well. She's helping behind the scenes. Hopefully we have no technical issues, but if we do, hopefully she can come and save the day. So just a more general overview. We're going to look at high performance design basics, and then we're going to jump into some construction types, then focus on windows, and kind of wrap up with this section on passive house innovative components. So a little bit more granular of a breakdown. The first 2 sections go for about 50 minutes. We'll take our first break for 10 minutes, then we'll do the second section, take a 5-minute break, and then finish up with the last topics there. So our first poll question is, what is your profession? And should that have been populated already, Katie?
Yes, people have been answering as they've come on.
Okay, thank you. So yeah, we're just trying to get a general sense of who's in the audience, and it kind of helps me tailor the presentation a little bit more to who's kind of listening in. So we'll give that a minute or so to kind of balance out and see what the responses are. Okay. Usually when it gets stable and I start talking about it, they keep jumping around. So there you go. But looks like a good amount of architects, engineers, some contractors and owners, which is great, other consultants. So it looks like a pretty good mix. Maybe give it a couple more seconds to kind of wrap up here. All right, I think we'll just keep moving. And our follow-up question is, what is the one thing you were hoping to learn about today? And if you're typing a phrase, if you use an underscore between the words, it'll keep them linked together. So just trying to get some general feedback of what people are interested in hearing about from the presentation. Okay, detailing, understanding basic principles, continued knowledge, the building envelope, installation techniques, that's a good one. Okay, a lot of responses here. Informed design decision, I think I saw. Okay, so I think we'll cover a lot of these in one way or another. So I think these are good responses, and thank you. So just a quick blurb, why are we here? In general, there's been a push for more passive house projects, especially in New York and Connecticut and Massachusetts. So it is kind of gaining traction, and you know, we're seeing more and more projects come up that are pursuing passive house. As Mark mentioned, there are some incentives available for the professional accreditation. So he had mentioned that, and I'm sure there's more information out there if you're interested in that. Some of the benefits, I think we'll kind of look at these later, but the key ones are, you know, obviously drastically lowering energy use, healthy indoor air quality, acoustics. It's, you know, passive house buildings are quieter and sort of a more resilient and comfortable building. And so this is workshop 1. We have other workshops that are upcoming, so stay tuned for those if you're interested to learn more about those specific topics. All right, so the passive house basics, we're gonna go through this sort of quickly. You know, I would think that maybe people who are listening have some idea of what passive house is. So we'll go over this for maybe some newer folks, but try not to get too hung up on it. So passive house is a building standard. It applies to newer and existing buildings. It's currently the most rigorous energy efficiency certification out there. Performance-based means you can design within your given energy budget. So it allows some flexibility in how you're meeting the passive house standard. There's a lot of attention to installation continuity, and also emphasis on balanced ventilation systems. And like sort of mentioned before, some of the goals beyond just energy reduction, you're getting a more durable building, a comfortable building, better indoor air quality, and, you know, on a larger scale, the carbon emissions reductions. Another aspect of passive house is comfort criteria. So this is also for thermal comfort, but also for potential risks of condensation. So this is analyzed during the modeling phase to make sure that there's not going to be any cold surfaces that could have potential risks for condensation, and that can lead to obviously bigger building durability problems. And so this is more so from the comfort aspect, but in a sort of typical building, you know, you might be inside over here, and over by the window, it's pretty cold, maybe they missed some insulation there or something, and it's sort of this not so comfortable environment. Whereas in passive house, everything is well insulated and air sealed, and sort of more comfortable place to be, so to speak. So some of the principles: thermal insulation continuity. So you have your insulation around the entire building envelope. Thermal bridge free, or sort of mitigation of thermal bridges, which are areas that bypass insulation. Solar control, more so applicable for sort of smaller low rise, but still a principle. Airtightness and the balanced ventilation. So it's a lot of these concepts, but we'll be talking about them sort of over and over again because they are so important, and then also hard to actually implement correctly if people aren't paying attention. So what can be certified? The term is passive house, but it basically applies to any building type. Townhomes, we have a lot of mid-rise to high-rise projects that are pursuing passive house. This is an office section of a building that's going for it. This was a factory in Sri Lanka, actually. So the term passive house really applies to essentially any building type. So some of these principles: continuous insulation. So you're essentially wrapping underneath the building, up the sides, around down to the roof. This is at a window opening, so you're thermally insulated essentially all the way around. The air tightness test, this is the blower door, which measures the air tightness, which is a test that we do at the end of the project. I think we'll get more into that in some of the other sessions, but this is really how you're graded on how well your air barrier system has been installed on your project. And balanced ventilation. So not only exhausting stale air from kitchens and baths, but bringing in fresh air and supplying it to living rooms and bedrooms and common spaces. So that's the sort of quick basics. I don't know if there's any questions there.
There's one question that came in fairly early on. Given that close to 80% of the current building stock will be still in use over the next 3 decades, can you speak to the ability to retrofit an existing building to the passive house standard?
Yeah, so I mean, that's obviously a larger policy, and I think beyond the scope of this presentation, but I would say that there are things that are trying to be in place to push for that. New York City has their Climate Mobilization Act, which pushes for carbon reductions in buildings for sort of first for the worst offenders, and then there are big fines associated with that. Also, New York NYSERDA is has a big push for retrofit projects and programs. So there are entities looking at it. Is it as accelerated or aggressive as it needs to be? That's to be, I guess, argued about. But I think there are entities that are looking at it and trying to implement things to work towards that.
Are all passive house measures and principles mandatory?
Yes. So you have to pass your blower door test for the whole building, or you won't get certified. Your ventilation system needs to be working and balanced, or you won't get certified. Like, you can't do an exhaust only system on a passive house. It just wouldn't work. So I would say those key principles are mandatory items. There is flexibility in how you meet those items, but you can't not provide say ERVs or something, and expect to get it past house.
On the third slide in, you showed minimum temperature variations as goals. Can you expand on that?
As what? Goals?
Yes. I think it's the third, probably the third slide into the main presentation.
Sorry, jumping around here.
Probably, yeah, it's probably this one.
I'm not sure I totally understand the question, but again, it's to prevent, it's to do an analysis to see if there's any potential risks for condensation on surfaces. So this is kind of an example where, you know, if a contractor says, oh, can we reduce insulation somewhere, or can we not insulate some surface? We would have to look at it to see if that's okay, and not, you know, if they're not putting any insulation 9 times out of 10, it's probably not. But maybe they have a spacing issue and they can't fit the full insulation. You know, if they use reduced insulation, is that still okay in terms of not being at risk for potential condensation in the future? I don't know, hopefully that answers it.
Yes, thank you.
Okay, so now we're gonna jump into sort of the larger typical construction types and then look at some details. So we do have another poll here, just trying to gauge the audience. What construction type do you most commonly see on your projects? All right, so still maybe shaking out a little bit, but good chunk is wood framed. Next up would be steel stud, and then a little bit of CMU maybe. So I'll try to keep that in mind. We do cover each type of construction just to go over them, but I will try to focus then maybe on wood a little bit more and the steel stud walls. All right, so wood framed, the first sort of task, right, is to do a red line air barrier test around your building. Can you trace the air barrier all the way around your building without picking up your pencil? Or if you know you have to, what is that critical juncture, and how can that air barrier be fully connected? So a lot of, you know, we'll look at in the next slide, a lot of projects are using the zip system, and we'll kind of get into a little bit more on that. But you know, from this larger red line diagram, then you really do want to drill into these more difficult areas, like where wall meets the roof, or obviously your typical window openings and things like that. So kind of start with this larger air barrier review, and then, look at these details, or if there aren't details for those areas, they definitely need to be shown and drawn so it's clear of how this air barrier is transitioning and connecting. So kind of starting at the foundation, we have under slab insulation. We also have insulation coming down the wall, stem wall here, and then coming up. And then you can see the exterior insulation starting here. And then we also have that, or they're calling blown cellulose, within the studs. So this is all of that continuous insulation that we've mentioned previously. And the dashed line, they're saying, is showing the air barrier continuity layer. So that if, this is the zip coming down, really the critical juncture to seal would be the bottom here. And you can see that kind of got missed here a little bit, and then the insulation is going over it quickly to cover it. So it's a lot of times a sequencing issue of making sure the air barrier is all done correctly before it starts to get covered up with the insulation. So then moving from the foundation kind of up the typical wall, we have our, regular sort of field of wall, again, here with the zip system, and the exterior insulation, the interior of that. And, but there are some tricky areas like these porches. So, how are you getting your air seal at those locations? Like these are kind of penetrating through the zip system, and then maintaining the insulation at that location as well. So this would be a detail that, would need to be blown up and shown a little bit closer to explain how those things are happening. When we were on site looking at this one, you could see daylight right through these. So how are they going to now go back and try to address these? Is it the zip tape? Is it the liquid flash product? Something like that. So these areas can definitely add up and really be difficult on your whole building blower door test. So, the wall itself hopefully should be fairly straightforward, although, we have had issues with zip, which we'll look at in a little bit, but also diving into and looking at these more tricky or critical junctures to make sure those are addressed as well. So also you can see here that they do have a pretty good seal from the zip to the foundation. And then this is some of the below grade insulation boards sticking up, and then the wall insulation from above is come down and meet it there. All right. So then really the next biggest thing that we see are windows and how they get installed in the rough openings. So, you do need to have pretty robust and good window details, and then also window shop drawings when those come in to review those closely to make sure they're aligning with the design intent. And also working with the window manufacturer, they can provide some guidance too on what you can seal, or if you need to leave the bottom open for drainage. It kind of depends on the window manufacturer that you're working with. But most times we're seeing either taping to the window or backer rod and caulk as the main air barrier connection from the window to the rough opening. And because the the air leakage can be coming from the window itself or from the window to the rough opening joint. We do air testing of windows. So, the first window that gets installed, we want to shroud it off and use some pressure and maybe some fog to see how leaky or tight that window is. And, make sure that the installation and details are all good before, building wide windows start getting installed all over the place. So, at least that's our method of checking that the windows as installed are going to be good. So we really try to focus this early in the process to make sure that all that stuff is sort of hashed out, before they've put in hundreds of windows on a project. And so moving up the wall, now we have, our wall meeting the roof. So we have the zip coming up, and then we have the spray foam in this particular project coming over and down, which you can kind of see here. So just making sure that those overlap and achieve that continuous air barrier. This particular one, I think we did see, I don't have the photo here, but we did see some areas where the foam was a little bit short, and then we were getting air leakage through those locations. So also checking the application of the foam to make sure that it's continuous. And this particular project too, I think they're coming up in a couple slides, some of the issues with the zip taping. They're kind of struggling with the tape to get it installed properly and get it flat against the wall and make sure that the roller is used and all that fun stuff. So it's kind of leading to our next question, but you'll see in a second, and then we'll look at some, I think, examples of the things that we've seen with the zip system. So on your particular projects, we're just asking what challenges have you seen with using the zip system? Penetrations, the taping, experience, yeah. Delaminating, yeah, that's not great. Training, yeah. Yeah, wrinkled tape or not adhered, all that's pretty common, unfortunately. Okay, so I think it's kind of well known, some of the sort of drawbacks, and I think we've been working with Zip much more closely on some of our projects, and trying to get them involved and out there as well to look at these things. Our kind of typical recommendation is to use a traditional air barrier like a sheet membrane or a liquid applied or something, but it often gets kind of pushed back, and projects are going with zip system. So we kind of need to work the best we can with their system. And on paper it all sounds great, but I think we've all sort of unfortunately seen kind of what can or does happen. So it's really sort of stressing the importance of getting this stuff installed the right way. So these are just some easy examples, these little fish mouths where it's not flat against the wall. On the tape, it says roll the tape, and Zip makes a roller that makes these little Z impressions on the tape so you can see or verify after the fact that it has been rolled. So you kind of almost, unfortunately, don't see that very often. This is an example of where the taping is kind of done quickly and then the insulation's going right away, covering it. So there's not much time to inspect it or verify that the taping is all good before it starts to get covered with the insulation. Some other challenges, a bunch of staples or ripped areas, areas where it's not really fully adhered to the wall. Again, that's the importance of the roller. Sort of these, again, more kind of fish mouths and areas that are not fully adhered. And, we've definitely had struggles with getting blower door numbers that meet the Passive standard using Zip. So it's not to say that it's not achievable or doable, but it really takes sort of another level of diligence on making sure that this taping is done correctly. And whether it's a third party, inspection company looking at it, or someone from the general contractors team or the architect or whoever, it really does need a fine review, because I mean, unless people feel otherwise, I think the standard is, get the board up, throw the tape on, sort of good enough, and that's about it. But that's not going to fly when you're trying to meet a Passive House level blower door number. So the projects that we have that are still pursuing using Zip, we're really hands-on, very closely scrutinizing it because of these sort of common installation problems. This was the spray foam that I was talking about. So I think it might be hard to see, but there's areas where if the foam isn't continuous, those can be air leakage locations. So something to be mindful of if you're using spray foam. Here, this was one where it wasn't fully filled around some framing, and we had some air leakage there. So I guess the caveat or word of caution is if you're using spray foam, it definitely is giving you the insulation and air seal in one product, but just be careful that it gets installed everywhere, because areas that are missed kind of can add up for air leaks and heat loss as well. And so this is a different project. This is Passive House that chose to do a traditional sheet membrane, wood framed, and you can see that it's just, I don't want to badmouth Zip, but this is a more sort of robust system. The air barriers in these big sheets that's going on the wall, they're being overlapped, so you still do need to be careful that it's flat and gets rolled, and use the primer and all that. But it's less prone to some of the challenges you see with the Zip wall system. So I mean, this is again our sort of first recommendation, some sort of traditional air barrier, and we kind of push hard for that. And unless then the project comes back and says, well, it's budget and we can't make it work and all that, that's obviously an issue. But we've seen this work, and we've seen this get passing results. So we would push for a more traditional air barrier if possible. All right, so that's kind of focusing a little bit more on the wood stuff. I know there's some people that use steel studs, so I'll spend a little bit of time on this section and then probably kind of breeze through the others if it kind of seems like no one really uses those other types of wall backup wall systems. So, so even though steel studs are thermally conductive, we have seen them been used on high performance buildings, and you can get to passive house levels of insulation. You do need to be fully filling the stud cavity and have exterior insulation as well. And your exterior sheathing does need to have an air barrier and all the joints sealed, but it is doable to get to passive house with steel studs, even accounting for the thermal bridging between the studs themselves. So this was just a photo of a project that was near one of our other projects, and I thought it was good because it kind of shows all these different stages of construction at once. So you have all of your steel studs here, right, that don't have any exterior sheathing on. Then as you're coming down, you have exterior sheathing on. They're getting some of their fluid applied air barrier on the wall. On the front, they're using a sheet applied air barrier. So, I mean, my guess is that this is probably going to be EFIS on the side and, maybe brick or some other type of cladding panel, something like that on the front. You can see some of the exterior insulation going here, and obviously not going to be a passive house because they have all these PTAC openings, but I think it was just a good kind of snapshot to show like all of the components of the wall coming together. So, if this was a passive house, it wouldn't be so much different. You wouldn't have the PTACs, but you would have the same sheathing, the same air barrier. You would have insulation between the studs, and then this exterior insulation would probably be a little bit thicker than what they have, but it's the sort of same wall system. It would just be kind of beefed up on the insulation aspect. And so that would be like a more kind of traditional approach. This is from 475. They have a lot of great resources and they sell a lot of these products, but they have some sort of different details and ideas of how to go about steel stud projects. So we have a pretty good guide if you're interested in looking at that. They use some different insulation types and membranes. So it's not to say that the kind of quote traditional steel stud wall is kind of the only way to do it. We have also seen in theory this system where the exterior insulation is also acting as the air barrier. And so again, this one they're showing the seams are taped, and then in this one they're showing it's a liquid sealant. And on paper it sounds great, but if any of these seams are not done perfectly, that is going to be a water leak too for your project. So I don't think we've seen very many of these. I know that a lot of times it gets pitched as, oh, you're eliminating sheathing layer because now this is acting as both, but we just say proceed with a little bit of caution, because then this is your only line of defense, and if that's not really robust, it could lead to some bigger issues. So this is another system that's out there for steel studs, but haven't seen it too much in person. All right, so CMU maybe one person voted for, so I'll go through these kind of quickly. It's similar. You have your backup wall, you have your air barrier on the wall, you have your exterior insulation. We have these standoff shelf angles for supporting the brick. So these are spot attachments. So you mitigate thermal bridging there. Air gap in your brick. This is sort of like a traditional cavity wall, and you know, you could have some insulation on the interior as well. And kind of similar to how we looked at the wood frame one, you have under slab insulation coming around on the foundation, and then your above grade wall insulation starting from there. So these are similar: backup wall, air barrier, insulation, and then you know, you can have insulation on the interior if it's needed. So this is the interior insulation that's installed, and if you are doing that, it's important to get all that in before all the studs and everything else kind of gets in your way. So that takes just a little bit of coordination on the GC's part to get that done. And then exterior should hopefully be fairly straightforward. More CMU, this was with a panel system, so same concepts: air barrier on the wall, insulation. Really the panel attachments are what's the biggest thing in terms of mitigating thermal bridging. So usually some sort of thermal shim or plastic behind it, and then insulation sort of all around it. You know, there's a lot of different ways to achieve that. And we'll kind of look at that, I think, in the last section of like innovative passive house components. So this is saying CMU, but it's essentially showing spray foam, which can be used on, you know, any type, but similar to what I was mentioning before, you know, just making sure that it does get installed continuously and there aren't sort of missing areas. Like this one, I think they had they kind of missed this corner, so they're going to come back and spray that, and then, you know, maybe some of these little areas that need sort of touch up. But again, if you're using foam, it's not a total fail-safe option. Just something to keep in mind. And just one sort of different backup wall we've seen used is this AAC block. So instead of using CMU blocks, we're using AAC block. It gives you a little bit better of an R value per inch, and also it is fairly airtight in itself. So that, you know, you're still putting an air barrier on it and doing your traditional air sealing and all that, but the block itself is pretty airtight. And we did a little mock-up and tested one of them and saw that it was pretty tight. So it only helps with the blower door number. So we have seen some more projects use this, either for the entire backup wall or for just portions, you know, say at a parapet or some other location. But it is sort of an uncommon product that's out there that we are seeing more and more of instead of a CMU. I think I'm gonna kind of skip these. This is it in progress. So, you know, it's essentially acting as the backup wall instead of the CMU. And it's this, again, same detailing of that's your backup wall now, that's your air barrier, and that's your insulation. And then this is just showing, you know, you could have different systems coming together. So here it's the same AAC block. We do have some poured concrete or structural column in this location. And then you have an EFIS system and a porcelain panel system coming together. So just making sure that those air barriers overlap and, you know, whatever the details calling for insulation. So you can see that this is the ephes, and this kind of stops, and it kind of stops over there. They brought the air barrier out, and then, you know, I'm not sure, maybe if they do a strip of panel here or whatever it is, just making sure that the insulation and air barrier is continuous, but also, even if it's ephes, to, you know, make sure that this air barrier is extended out, so that when you come for the next section, you can overlap and continue on your way with your continuous air barrier. All right. So that's the sort of first section. Tried to focus a little bit more on the wood stuff, and steel stud, it seems like what most people are working with. So any questions there, Katie?
Yeah, we have quite a few. So I'll start out and you can let me know if we need to move on. So XPS has a high embodied carbon. Do you know of any other alternatives that might be lower?
Yeah, I mean, we have seen more projects pushing for mineral wool, also from a fire perspective. So using mineral wool exterior in the cavity, or behind metal panels, obviously, or things like that. So I do know that XPS, I think, is reformulating a little bit. I did see something from Dow that they're doing a little something to change the color, but that also does have some impact on, you know, how much, I guess, energy goes into making the board. It's a little bit unclear of what the actual impact is. But yeah, I mean, if you look at like 475, they have a lot of what I'll call like alternative insulation products that are out there. I think they have like lamb's wool and Gutex, which is wood-based, things like that, but we haven't seen widespread use of those yet. It's more so XPS and some transitions to mineral wool as the sort of primary insulation products.
Do you have any experience with prefab wall systems, and do you think they can be successful?
We have had a couple projects use prefab. The big Cornell Tech project was prefab. It can help, but it also, you're not going to avoid everything that you would hope to avoid by being panelized. So, you know, the panel itself is made in the factory and can be made great. You know, it could get damaged during shipping or damaged during storage on site. And then on site, you have to make sure you're making all your panel-to-panel connections to be very robust. So we have another project now, wood framed one, that is panelized, and you know, it's kind of surprising, but some of the stuff out of the factory was so, you know, you'd think it would be coming pristine and, you know, everything perfectly taped out of the factory. So there's a little bit of lacking on that. And then again, you still have to do these panel-to-panel connections on site. So it can help somewhat, but I wouldn't say it's like you know, definitely go panelize all the time, because it's going to save you a bunch of headaches. I don't know if that's totally true, but it can help in that if a lot of it is done properly in a factory, it'll minimize the amount of additional air sealing and air barrier stuff you need to do when the panels get put up on site.
Right. It appears that most of the issues are an installation issue due to appropriate training. Do you think that's the main reason why passive house cost is higher?
I don't think that I don't think passive house should cost more, because people aren't using products properly. Like, you know, all of this stuff is out there. If it, you know, a typical project that's not using or not doing passive house but is using zip, you know, all the literature from zip clearly says, you know, all the stuff. The wall must be dry and free of dirt. The wall, you know, any gaps larger than whatever it is, say ½ inch, need to be filled with foam or something as a backing bridge. All the tape needs to be flat and rolled and pressure adhered. So all of that stuff should, in my opinion, should be happening anyway. It's just that because, you know, no one's maybe looking at it so closely, it kind of just flies, and that's what it is. So I don't think that passive house should cost more because of things that should be be done anyway. But I do agree that it is training. You know, a lot of times it's like, hey, here's this roll of tape, go tape this entire wall. You know, but maybe they didn't even give the installer a roller or let him know that he has to roll a tape, or explain the importance of, hey, if this tape isn't good, you're going to get water into the building, which is going to be a problem, you know, in the future. So I think training obviously can go a long way, and explain to installers why and how things should be done. But I don't know, again, if it should cost more because that's what they should be doing in the first place.
Do you have any experience with the RZIP system?
Yeah, so our zip is the zip system that has the insulation already kind of fused into it. So it definitely helps in the aspect that you have the insulation. You have some exterior insulation kind of a part of that, and you can get them in different sizes. But it's the same, you know, challenges as the regular zip in terms of getting the panels to align and be taped properly, and, you know, avoiding the fish mouths and rolling it and all that stuff. So the R definitely helps from the insulation aspect, but from the install, it's similar to the just the regular zip board.
Of the main areas of thermal improvement, can you speak to which is the most important to get correct?
I mean, the typical wall is, you know, really the majority of your wall system. So that should be pretty robust. I mean, it depends on the project and what they're doing, but, you know, some of the slides we were looking at have, you know, 4 inches of exterior insulation. Some might have a little bit less, but then add more on the inside. So really that's the kind of biggest aspect. And then, you know, you probably are going to have some little thermal bridges around. Maybe you have some supports on a roof for a PV system if it's a flat roof, or a canopy connection coming through. So those all can get detailed fairly easily with the thermal break products that we'll look at later. And they are important to do, but they're not, you know, a huge part of the building's thermal envelope. So I think you want to deal with the bulk of it, the walls, the roof, and get that all right. And then, you know, these other ones, smaller, you do need to mitigate, but they're not going to have as much of an impact as your, say, entire kind of wall system. I think that's the last one we'll take, Katie.
Okay.
All right, so we'll take our first break here, 10 minutes, and then we'll come back, and start looking at some windows. All right, so we're back. Got a little feedback that there might have been an echo, so I'm trying something a little bit different now. I don't know if it sounds any bit better or different, Katie.
Yeah, I think you sound good.
Okay, thanks. All right, so we'll get started on our next section here, high performance windows. And we're going to start with sort of just a general question to see what people are thinking. So what's your biggest concern regarding Windows? Your tightness, code, operability. Yeah. Readily available. Yeah, that's a big one. Infiltration, flashing, detailing. Yeah, performance and cost too are big ones. Okay. So for Passive House windows and doors, we're using some pretty good windows and doors in terms of thermal values. So right off the bat, they're sort of thermally improved over a sort of go to the store and buy just some regular sort of typical window. So that's one aspect, is that they are more well insulated to begin with, and they also do close more tightly, which we'll look at in a little bit. So there's obviously the selection of the window itself, but then from the sort of installation and construction side, the installation of the window, and if you do need to over insulate the frame, how is that being achieved? With we'll look at that, I think, in maybe a slide or two. The airtightness of the window itself. So a lot of times, I don't want to say a lot of times, but we have seen projects where the window is supposed to be this great airtight system, has all the testing data in the lab about it, and then on site it's not maybe closing so tightly, or what's going on. So is that just final adjustments that need to be made, or is there sort of a larger issue that might need to be looked at? And then the airtight installation of the window into the roof opening. We're also saying Passive House doors were applicable. Typically, projects don't have too many exterior doors. We did have one project that had quite a few balcony doors, and that was an application where those were all actually Passive House doors for all those various balconies. So, it's just a kind of cut through a window. We're seeing more and more triple pane. We have some projects that can still do double pane and be okay, but triple pane is kind of becoming more of the common. Also, if you're near, or at least projects that I've been working on, if you're near a subway or a highway, we've been seeing triple pane as well. I think for noise issues. And the actual window itself, how it closes, it has a pretty robust gasket all the way around. We're commonly seeing tilt and turn type of windows. Again, the next slide I think will show it a little bit better. But they have more sort of engagement points on the locking mechanism, so it pushes really tight against this gasket for a more airtight seal. And you also do have to look at the spacers. Those do have an impact as well on the overall performance of the window. So a little bit more that goes into it on the design side of picking which glass package, which spacer, and which framing system. That's all going to kind of come together. And so these are kind of two pretty common window types. This is a UPVC option, and this is metal option. So again, it's this tilt and turn. So they have handles that when you close it, it really presses the window, the operable portion, against this gasket all the way around. So you can see multiple locking points and dual weather seals. It can accommodate different glass packages, and again, if you need to look at the acoustics, that's something to look at as well. And yeah, I mean, this is really what we're mostly seeing is tilt and turn UPVC, or that you can see the metal option is similar, and that has some more kind of insulation in the frame here to help it out because of the metal. This is their gasketing system. You can kind of see it here, that how these kind of push closely together and tight. You can see some more insulation in the frame there. And this is a triple pane option. This is a double pane option. So this is sort of the general, I guess, types of windows that we're seeing being used on passive house projects. So the installation detail of the actual window can have an impact. So these are some sort of generic slides, but if you have a window that's just installed kind of flush and straight with the outside, you know, you can have a sort of cold or weak spot there with the insulation. So, I mean, this isn't, you know, shown really, I think, realistically, but it's essentially showing that if the insulation is coming up and wrapping over the frame a little bit, it's going to help mitigate that heat loss. So, you know, if you had insulation that on the outside that came up and covered here, it would definitely slow down this heat loss. So that's also something to keep in mind in the sort of design and detailing parts of the project. And so this is from one of our projects. It's definitely a lot of markups and kind of tricky details, but sort of to try to run through it. This happened to be a CMU backup wall. And so they had their air barrier here, the insulation here. They had first they had the air barrier come in and wrap the rough opening. Then they had these fiberglass closure pieces, which we'll look at in a little bit. They had the window straps come back and those all be caulked. They had the exterior caulking of the window to the brick. This was actually filled with spray foam, and then they had an interior caulk there as well. So this particular detail is definitely a little bit tricky. There's a lot of different things to be looking at. So here up at the head, they had this offset shelf angle, again, that closure piece, and then backer rod and caulk on both sides. In the middle, I think they actually ended up doing mineral wool in here. It was a little bit easier for them to do that rather than do the foam, and the foam kind of spills out and they'd have to cut it back. So I'm pretty sure they did mineral wool in those areas. And then here at the bottom, they had the window actually sitting on a piece of Armatherm, which is a high compressive strength insulation. And so, you know, a lot of kind of tricky stuff going on here. So really the best way to, you know, obviously you need to draw it and show how this all comes together, but really the mock-up is the kind of place where it all sort of comes together and you can see what's going on. So here they had that, you can see this is the air barrier kind of coming in, the rough opening. They have their insulation, they have their offset shelf angles. This was that piece of Armatherm at the bottom where at first they were trying to use a liquid air barrier on it, but due to temperature or adhesion issues, it wasn't really sticking. So they actually changed that to wrap it with this sheet membrane instead. And then, so that's that piece of it there after it's been wrapped. Then they're using this closure piece all the way around, and this is fiberglass, so it's not as conductive, right, as if this was all pieces of metal, which would be pretty big of a thermal bridge. And so that is getting finished to the brick, and then they kind of came back and caulked everything. I think we'll show in a little bit. And so this was the actual window now coming in, and you know, that getting to that edge of the brick, which is this location here. You know, making sure that they have enough gap there to get backer rod and caulk, and then making sure the spacing at the bottom is there. And yeah, I think I mentioned this before, but the initial idea was to use foam, but as you can see, it kind of spills out, and then they'd have to cut it back, and then, you know, there isn't going to be space for the backer rod. So they switched it to mineral wool. So they would do the caulking first, and then from the other side, put in the mineral wool, and then do the caulking from the inside. So this is kind of the final product. You can see everything is sort of gooped over and sealed. So the edges of this green girder are sealed. The clips of the window are totally sealed. The edge of this whole membrane is sealed. So it's a pretty robust system. And I mean, this is a project that had, I think, fairly complicated details, maybe too complicated. They probably could have done something to simplify things, but just kind of where it ended up. So just showing that even with levels of complexity that, you know, may not need to be there, but are, it can still be detailed in a way to be a pretty sort of robust, airtight system, and also be meeting all of the thermal bridging, or sorry, thermal installation aspects of the window install as well. This is from a steel stud project. So you can see, again, a lot of similar interior and exterior backer rod and caulk. Here to help with some of the thermal bridging mitigation, they're having an extra piece of insulation on the interior here to, you know, sort of reduce the heat loss through this pathway here. On the outside, you can see this is the ephes, and it's coming up somewhat. Maybe not a great detail. I think the jam shows it better because you do have this little air gap here. But you do have this extra insulation on the inside, which is helping with thermal bridging. And I think really here on the jam, it's showing this over insulation. So, you know, you're not getting this sort of direct heat loss through the windows. It's sort of more gradual with this over insulation. And this is the, you know, again, their mock-up. We had seen it before all of this exterior cladding was done. Like they just had the wall and the window in, so you could look at all these sealant layers and all that before it all gets covered. But kind of similar to the previous one, it's this sort of double back barrage and caulk scenario. And so this was the quote interior view, and you can see that they've wrapped the air barrier in the roof opening. They've gone pretty heavy with the caulking around each of the clips and all the way between the window and the roof opening on the inside, and then also on the outside. So we have seen this work as a pretty good system. I think I might have some more slides of different projects that have used tapes, different air barrier tapes on the inside. It's, you know, it is achieving the same thing. It's just a different approach. So on wood framed, you know, I think this is definitely an area to be a little bit more careful. This was a project where they had passive house windows, but they didn't have any sort of nailing flange on the window itself, just sort of more common, I guess, for wood framed, right? So then that would go in and you would, you know, seal those sides, usually leave the bottom open, and that's kind of call it a day. So this was trying to tape to the side of this unflanged window, which is really, really difficult. I think we'll show in a little bit. And also, this was one of the first couple windows that was installed that we were going to test as a mock-up. But they had already, you know, started a little bit of siding and insulation and all that. And, you know, we were getting some pretty rough numbers. We were seeing fog come out everywhere. So we had to ask them to sort of remove this stuff to see what's going on. And as kind of look a little bit closer here, and we'll see in the next slide, you know, the zip taping here was pretty rough. And they're trying to sort of tape up to the side of this window with really no surface to adhere to. Obviously, this is going to be a water pathway. You can see they did try some foam on the inside, but, you know, I think beyond air, this is pretty bad from a water perspective. Here you can see they have some missing holes in their zip system. Obviously, those should be sealed with the tape or the liquid flash. Kind of have a lot of taping layers going on here, and they're not really sticking very well. You know, a little fish mouth here. So, you know, the attempt was to try to, you know, combat it by just caulking and foaming everything on the inside. And, you know, then you kind of start chasing your tail, right? Because you have to kind of get every single seam in the wood because it can kind of keep sort of spreading out on you. So, you know, even areas like this that look like they're well foamed, you know, you can see it's kind of a gap there, and that's an air leakage point, and they're trying to do little bits of caulk, and it kind of was getting to be very difficult. So I think what they eventually came up with was adding around the four sides of the window, sort of bent piece of metal that was acting as this nailing flange, so they could have something to tape to, and then we had to make sure that was okay from a thermal bridging perspective. But a lot of this was different than I think how it was shown on the shop drawings, and so these are some pretty bad examples of things to try to avoid, and hopefully these get caught in the shop drawing phase or design phase and then shop drawings to make sure that like what is this zip tape actually going to be going to. I think the initial was that it was going to go to maybe the face of the frame, but where the windows had to sit, these kind of had to be pushed out a little bit, so that wasn't going to work. So those are sort of all early design items that should be worked out. Some sort of better solutions we've seen are where the window is in the same plane as the zip, so you can do either taping or backer rod and caulk around and get it a little bit more easily. Again, this window's sitting out a little bit, so it just makes it much more difficult. And here you can see there's not much surface to actually tape to at all. So definitely some struggles with the wood framed installs. And maybe go through these a little bit quicker. So similar AAC and CMU. This is kind of really one of the better details we've seen, whether, regardless of backup wall type and all that, you have your backup wall, you have your window that's in the same sort of plane as that, and then it gets sealed either, taping or backer rod and caulking all the way around. And, we've seen this approach on a lot of projects, and it makes it just very easy in that you have your window, you have a sealant layer, and then your transition to your air barrier. And this is, connecting all those layers. You also do have the sealant on the inside as well, and the air barrier wrapping in. So like here, you can see that they have the sheet membrane. This is the CMU wall wrapping in. They have the whole edge of it, totally sealed. They have the window in. They have the caulking between the window and the rough opening, and then around pretty heavily on each of these clips. So, and then obviously the caulking on the outside, and it's definitely a lot of caulk. You'll hear the installer say how many tubes of caulk they go through and all that, but you kind of really need this level of detail. Sometimes if you caulk and kind of stop at each of these clips, you're going to get leakage underneath the clip and the shim that it's sitting on. So it is actually pretty important to make sure these are fully embedded with caulking or tape, depending on what the strategy is. So these are two different projects, which I'll look at a little bit. Call it 211, it's part of the address, but so for this project, they did AAC block, and then also they were using an air barrier tape on the inside for their windows. And during the one of our tests, we did a guarded lower door test where we try to isolate one floor and get an air leakage reading for that floor. We were noticing the taping was actually pretty good. We were noticing there's some movement of air around the windows, and you can see sort of this hairline seam here and this gasket kind of not so great here. Maybe not in this photo, but some of these other hairline seams. And this was sort of a unique project in that it is actually doing the glazing on site. So they have the frames, they would get the frame, they would install it in the roof opening, and then they would have someone come with the glass and install the glass separately, which is kind of rare, but you know, it was honestly a little bit of a surprise to everybody. But you know, with that, you're now trying to install glass on a dirty, dusty, cold, windy construction site, and you know, get these gaskets to really be working properly and being effective. So we were doing additional tests, and we were seeing that you know, we're still having issues with these, how the glass was getting installed, and still getting some air leakage through the windows themselves. And you know, got to the point where they didn't like the way that, you know, we were doing a test. They wanted to bring in a third party to do testing as well. So this is a different company doing some testing. They have their big fog machine, and you know, we were seeing a lot of smoke still coming through these windows. So you know, and the manufacturer got involved, and the installer, and everybody was trying to see what we could do. And you know, there's a pretty extensive process for how the glass needs to get installed. I think it's maybe like 12 steps or something, in terms of there's different gaskets that are in there, and spacers and things like that to hold the glass that need to be followed in order for it to achieve the airtight tightness that it needed. So this is, you know, them doing some more testing, us doing some more testing. And so, you know, eventually they did have to go around and make adjustments to the glass to make sure that they're achieving the air tightness that they're supposed to be getting out of it. And, you know, some more testing. So there's a whole bunch of testing on this project. And, you know, luckily they did still meet their final whole building blower door number. But it was definitely an ongoing struggle with everyone to make sure that these windows are actually, you know, getting the performance from them that was anticipated. So a different but related project was 511. So they were using the same installers, the same windows, the same glass, all that. And so fortunately or unfortunately, they learned a lot of stuff from the 211 project, and they had their mock-up, and were, you know, we were there, the testing agency was there, the architect, you know, the whole crew was there, and, you know, the window rep was there, you know, watching how the glass actually gets installed step by step, you know, making sure these gaskets are where they need to be, these sort of like setting blocks are where they need to be, just so everyone would be on the same page of how this was kind of going to be improved, I guess, from the other project. And also they did make a little checklist, which I'll show, I think, in a couple slides. And that would be completed by the installer and taped essentially to every window to show that they were following the steps, and at least there would be some responsibility or accountability of, you know, who did that window, and was the glass actually installed properly on those windows. So we were at this project and we were testing the window itself, and definitely got some pretty good numbers right off the bat. We weren't seeing the air leakage problems like we were seeing at the other projects. So we do think that they were following the class installation guidelines pretty well. And then, you know, some more testing. This was like one of the first ones. This was, you know, maybe another one that they had just gotten in and were trying to see how they were doing. So I think I had a different slide, I'll show it bigger, but this is like the checklist that they were using to make sure the glass was getting installed properly. They also did have a lot of balcony doors, so we were testing different balcony doors. I think they had a good amount of these. Forget the number, but it's maybe I'll be able to tell from the next slide, but it was quite substantial. So we were kind of worried about these being well air sealed, and using our similar procedure of testing the balcony doors to make sure that they were airtight. And in one of these first tests, actually, the door itself was okay, but we were getting some leakage through the AAC blocks. So they really had to continue the air barrier down to really allow us to get a little bit better of a number on the test. But visually, we could see that the doors themselves were doing pretty well. And so this is the project. It's sort of these two buildings that are connected by this little hallway here. These are going to all be balconies, and then the whole back has large runs of balconies down the whole back. And these are a couple balconies as well. So again, we were obviously worried about the windows, but with the windows, they'll kind of lessons learned from the other project. Still had to keep an eye on it, but weren't as worried, given that we were getting some better numbers on that. So kind of keeping a more close eye on these balcony doors. And it's kind of blurry, but they had the date. They had all the steps listed out of what needed to happen for the glass to get installed the proper way. And they had the technician who installed it, and their kind of sign off that yes, we followed all the steps on installing this window. And again, it was definitely a learning curve from the first project. So I think with this whole kind of story, it's like, we weren't expecting this to be glazed on site. So obviously, if you can avoid that, that's the best. But even for projects that obviously aren't glazed on site, it's coming from the factory, we have seen some issues with, windows not closing tightly or gaskets not hitting properly and all that. So it probably still will take some level of adjustment from the window installer or the company that's representing the window to come and make these final adjustments for anything that might come up. So this is a view of the back. You can see there's quite a few balconies here going up, and there's more coming down this way. And so as we're getting towards the end, we did some more testing on these as well, just to make sure that we're on track and we're getting some pretty good numbers. And, they also, this project did have a successful whole building blow door test as well. Again, I think my colleague Chris here, he was a little bit more worried about these balcony doors than I was, but they did get a pretty good number overall in their whole building test and did okay there. So this is also, I guess, to show at least our approach is to really focus heavily on the windows themselves being installed and the actual installation conditions. The wall air barrier and all that is an area of concern, but hopefully is a fairly robust system. So really it's these windows and the window installations that take a little bit of extra effort to make sure we're really getting them installed properly. And then similarly, we do have some existing buildings that are retrofitting to the passive house through EnerFit. So this is a project that was going for that, and we're doing testing of their windows as well to make sure that, again, same stuff. Is the window closing tightly? I think these might have been fixed, so if that's the case, that wouldn't be the problem. But how is it getting installed in the rough opening, and is it being sealed and connected to the other air barrier layers? So we have different kind of tools to do this. We're using a duct blaster, which I'll show on the next slide, and then there's different rain configurations, so you can figure out what your airflows are. So here we have, it's kind of out of sight, but the duct blaster, which looks like this, and we have this device called the micro leakage meter. It's sort of a special order item from Energy Conservatory, and it allows to measure, very low flow rates, 2 CFM and under. So, when we're evaluating a window, and I guess for sake of ease, you will, say it's going for FIAS and it's a larger building, they would be allowed 0.08 CFM per square foot. So that's sort of what we're calculating as the target. So we can get some pretty low targets given the area of the window. So we found this device to be really helpful in that we can measure pretty low flows. This one here is it's ring 4, or the D ring for the duct blaster. That goes down to 2.4 CFM. So if your window is big enough that your target is above that, you could use this one instead. The nice thing about that is you don't necessarily have to use the software. You can just kind of run it more manually and use a chart to get your flow rates, or you could hook it up to the computer, which I kind of like to do, so you have all this data recorded and you can kind of see what's going on. And again, not many projects with balcony doors, but they would be treated similarly as if they were windows on any sort of typical project. So testing and more testing, our sort of milestones are, we always want to test the first window installed in a mock-up, whether the mock-up's separate or on site, on the building itself. And then, really make sure that that's good before we're moving forward. So if it takes a couple times to get that mock-up right, so be it, but it's much worse to have a whole bunch of windows installed that aren't really great in terms of meeting their air tightness target than spending all that time up front to really get it down before the contractor starts running with it and installing windows throughout the project. And then 2, we also do usually have the window manufacturer involved, so they know if we're doing a test, they can make any adjustments that they feel are necessary to represent how the window would be delivered at the end of the project. Sometimes during construction, there's dirt and stuff that gets, debris that get in the gaskets. Sometimes certain windows are used as access to the outside for scaffolds or other things, and gaskets get stepped on or wrecked and all that. So we do want to give them a fair shot to represent how the window will be kind of delivered at the end of the project. So sometimes the window installer or the representative from the window company might, come the day before, come the day of, and do some kind of adjustments and cleaning and all that to show, this is the condition that the final windows will be sort of delivered in. All right. So that section was a little bit quicker, but I think we went longer earlier, so I think for timing we'll be all right. But are there any questions there, Katie?
Yeah, there are some questions that came in. How does the water drain out of the windowsill?
So on a lot of our commercial projects, because we're using these better high performance windows, the manufacturers don't have an issue of caulking on all four sides. On the wood frame projects, it's definitely depends on who you ask. Certain window manufacturers are adamant that you leave the bottom open to let it drain. Others are not so worried about it. So it's sort of a, it depends, I guess, kind of answer. You know, and the more traditional or, you know, kind of safer approach is to leave the bottom open for drainage. But you know, by asking the manufacturer what they require is really going to dictate that. So again, on our CMU and steel stud and those projects, we've definitely seen them caulked on all four sides. The wood frame gets a little bit more intricate on what you do there. But I think it has to do with the quality of the window too, which can impact that decision. So if that's the case and you do need to leave the bottom open, really you have to focus on the interior caulking as the air barrier. So it kind of depends, I think, on which product you're using and also the take of you know, the manufacturers and the architect that's involved with the project.
Okay. In reference to slide 80, what's the likelihood that a crack would develop between the horizontal joint in the stucco and the corner of the door opening?
I'm guessing they mean here, but I'm not sure. I think maybe they leave some space and, you know, do background sealant to finish it. I'm not really sure. It's hard to see from this photo. I mean, the intent of this slide was more more so to show the blower door type of stuff, but yeah, I'm not positive on that particular question.
How do you do cantilever balconies without massive heat loss?
So they did use thermal break, the shock isolators, which we'll look at in the last section of this sort of innovative PH components section. But each of these has essentially, it's a thick piece of foam that has rebar going through it, sticking out both ways. That, you know, you pour concrete on one side and you pour concrete on the other side. It's structurally held together with the rebar, but you do have a pretty robust layer of foam separating those two surfaces. So again, we will look at that in the sort of innovative passive house component section, but the one that we see the most is shock. SHOECK. Something the spelling is a little bit weird. We just pronounce it shock. Isocorp is the product. I think some other companies make them as well, but that's really the main one that we see. And you know, there is a lot of engineering that goes into that. The structural engineer has to obviously look at that, and Shock has their own engineers as well doing calculations. So there is some definitely thought that needs to go into that. But yeah, that's how you can thermally isolate all of these balconies.
As the buildings age, do windows need to be resealed or adjusted?
Yeah, I mean, the exterior sealant is definitely going to fail at some point, right? But most projects we're seeing are using a pretty high quality silicone sealant, which has, pretty good longevity and, um, you know, retains its sort of elasticity over time and all that. I think like any other building component, will it need to be recaulked or fixed? Probably, yes. But, I think right off the bat, these windows are a little bit more robust with their gasketing systems and how they close more tightly. And, um, but yeah, I'm sure windows will definitely need adjustments, especially tenant use. Are they slamming windows shut? Are they, breaking things, all that kind of stuff too. So, um, yeah, I don't think you can say that any building component is going to last forever, but they are trying to use some better quality stuff from the beginning, not using cheap, caulk that's going to fail quickly, or sort of cheap window components that are going to just sort of fall apart. So.
In relation to testing windows, do you create a custom sheet over the window and tape to the sides of the building and the testing duct fan? Or do some testers have a few sizes of standard plastic sheets that can be reused?
Yeah, it's kind of custom each time. Um, at least the projects that we're seeing, it seems like every window size is slightly different, or the rough opening cut is kind of different. And what you can try to do is, like, say on this one, if you bring it past a little bit, you do this test, and then you can kind of trim this edge off. You can maybe reuse this one more time or something like that. But yeah, it's a little bit difficult to make something that's easily reusable, just because the variation of the sizes of windows on every project. You can see like this other testing company, this is a third testing company, they build a sort of little frame out of some small lumber. These guys make a big box out of lumber. They like this kind of thing, they would kind of leave on site, so at least they could use it a couple times on windows that are similar size. So they have, their wood framing and the plastic around it, and they're using foam to seal it. Our method is a little bit not as robust in terms of building, big kind of wood structures. There's just more logistics involved with, getting this to the site or building it on site, and the time and materials and effort involved with that. So the plastic sheet has been working for us. But yeah, you don't get too many extra uses out of them, unfortunately.
Can you recommend some high quality caulking options?
Sure, yeah. I mean, we see for exterior, we see Dow 790 or 795 pretty commonly on for windows. There's other brands. I think it's, don't quote me, Tremco Spectrum, something like that. So these are all, again, more generally just construction grade, high quality silicone sealants. And I think if you look at one of those, like the 790 or 795, and do comparison chart, it'll show that compared to all other different silicones. Obviously from Dow, they're saying why theirs is better, but not to say you can't use a different um, product. So yeah, the Dow ones we see pretty regularly.
Would you recommend a liquid applied air barrier or barrier over a zip tape?
I mean, that would be good, but I think that would be sort of defeating the purpose of going with zip in the first place. So like the whole idea of zip, right, is that the green portion of the board is the air barrier and you're really only taping the seams. So now if you're taping the seams and putting an air barrier on top, you know, why even use it? Just use regular sheathing and then put the regular air barrier on. I think the one improved kind of way to potentially do zip is to use their liquid flash system instead of the tape. So that would be, you still have your panel joints, but the liquid flash is like a liquid. So you kind of sausage it out, you know, zigzag it on the wall and, you know, press it flat, and it's more robust in that you don't have the fish mouthing issues and rolling issues and all that. So yeah, I think the liquid flash would be a better option, you know, and not necessarily doing an air barrier over the taping it. You know, I think that would be a hard sell to owners of adding that additional product.
Okay, that's all for now.
Okay. So we'll do another little break, 5 minutes, and we'll come back. We'll kind of finish up for the day with air barriers and some of the innovative passive house components. Okay, so we'll keep moving here. Air barriers and insulation. And we have another poll here, just trying to gauge, again, kind of what people are mostly seeing out there on projects that they are working on. All right, so a little bit of a split. Some fluid applied, maybe like a sheet membrane, lots of house wrap, some zip. Let me give it another minute. Okay. So the follow-up question, what do you see as the hardest part of installing an air barrier? Taping, sealing, continuity, consistency, joints, detailing. Lousy, I think I saw in there. Maintaining imperfections. Yeah, I think the biggest ones can continuity, detailing, taping. Okay, so kind of just to start off, I think regardless of what system you're choosing to use, whether it's a sheet membrane or a liquid applied or, you know, like the zip system, there's always information from the manufacturer on how this product needs to be installed or how they intend it to be installed. So the first thing is to know what that information is and have it sort of readily available. You know, if you're working with a contractor that's been installing this stuff for years and they actually do a good job with it, you know, they're not going to have the instruction manual right next to them on site, right? They kind of know what they're doing. But if it's someone that's working on, a high performance project for sort of the first time. They've maybe done some just sort of code only or base level of detailing. Maybe they need to have this and read, these directions and see what the manufacturer is calling out. Like this one, they're saying all these different substrates, how they need to be properly prepared. And then, how you're actually directed to install the product itself. So, these are there for a reason. The manufacturers, I do think, want you to succeed in achieving what the intent is for your project. So they have this readily available. And the other aspect is to, involve the product reps as often as you need for help. So a lot of times they'll offer, to come out to the site and look at some application, or especially if there's some sort of difficult detail or installation that's taken place that we've seen some things happen when things get washed away with water from rain events and things like that. And the product rep is definitely helpful to get involved. And they do offer another level of support on how to properly install the products, sort of regardless of what system you've chosen to use. So this one, more so for liquid applied. I guess it could apply to zip too, but what we'll call uncommon tools, sort of some simple things that should be used during air barrier application. So this is a liquid applied system. So this is a wet mill gauge, so you can poke it in and see how much coverage you're actually getting with the air barrier. So if you're putting on enough of it. This was from a mock-up demo where they're using sheet membranes, but you can see that they have the rollers for putting the primer on the wall. They have this sort of spatula thing, you can use that to help sort of push the membrane into corners. They have other tools like there's a press fix, which is from 475. It's a little sort of rigid credit card that can help with that kind of stuff. You can see that they have the roller. So, after you've put on the sheet membrane, you use the roller to make sure you're getting the adhesion. That would be similar for zip. The zip has their own roller. It does little Z's, or you don't have to use that one. It does make verification a little bit easier, so you can see that. But some of these things that, if you look at it, it's like pretty simple. These couple little things, like if they don't have these, they're probably not installing the products properly, or you're not really sure, right? So these are some good indicators that whoever's doing the installation sort of knows the system and knows the things that need to go with it, and also has the proper tools needed to do the proper installation. So again, regardless of system type, we really do think mock-ups are pretty critical component of any project. And it allows you to see how good or bad something is being installed. So this was a fairly recent wood framed one. They, first they showed it in 3D of what they were going to build, and then this is them building it in progress. So they have, an outside corner, they have an inside corner, they have the roof connection. The zip taping is mostly done. They still have to finish some of it here. But this is an example where you can see, is the surface, cleaned or, free of dust? Is the tape flat? Is it rolled? Is it lapped properly? You don't want to have the reverse lapping. I think their details not sure if they're showing it here, but the idea was to do the taping first and then add some sort of blocking after to have these overhangs. Otherwise, trying to tape, if that was installed first, is sort of a nightmare. So making sure that that is happening, like the tape is all finished underneath, and then this piece is added sort of second. And you know, they have their window rough opening, so they would do a mock-up of that as well. I mean, this is more just focused on the air barrier aspect of it, but yeah, we're definitely push for a mock-up on no matter kind of what the project type is, to really see these details, and then if there are any issues, we can talk them through with the installer and how they can sort of correct it moving forward. So this is another mock-up that we saw on one of our projects. They were actually calling for just like a little sort of half wall, but the contractor was kind of, you know, fairly well bought in on Passive House. So they said they wanted to make like a 4-sided one and put a little roof on it and actually test it with a blower door to see how tight it was. So that was kind of cool. We'll look at that in a second. They went a little, you know, above and beyond, calling out each component and who the contact was and what the, you know, any sort of extra notes. So really a detailed plan of how this mock-up is going to be. I mean, this is a little extensive. It's not sort of the common approach, but it was kind of cool to see that they're, you know, really pushing to have everything there and looked at before they started on the building. So this is that mock-up. You can see that it does have the 4 sides all the way around. The one side had the window. The other side had a door. You can see that there's 2 different air barrier systems coming together. So, you know, talking to the manufacturers to see, you know, who can overlap onto who in terms of compatibility and all that. This is getting the window installed. This was doing the taping to make sure that you're getting enough adhesion onto the frame, and then, you know, it's coming further back enough to overlap with this tape. So kind of this is where all this stuff really gets sorted out. You know, they thought that they needed maybe a bigger tape and actually say, well, actually we could use this shorter tape, or vice versa. So not that you want to be changing a whole bunch of things, but this is sort of that last opportunity to say, hey, we, you know, instead of this, we could do that, and it would be a little bit easier and still achieve the same thing. That's kind of where you would pick up all that kind of stuff. This is the other project. They did a similar thing. They had 2 air barrier systems. They didn't connect them just yet, but you can see that they're going to tie those in. They had a pipe, you know, representing a pipe coming through the wall. This was going to be a door. The window was on the other side. So similar thing in that they essentially built this little thing, and you could put a blower door here and see how well all of these systems are doing together. The roof, I mean, it's just temporary, just some plywood to block it off, but it kind of gives you some insight into the walls and the window and that kind of thing. These I might try to go through a little bit quicker because I don't know how relevant it is to the audience here, but this would be a you know, liquid applied air barrier, and they have all these different clips that are going to be for a panel system. So you can see that these are not metal, I think they're plastic, but you can see that they're intermittent, so you can keep the mineral wool insulation, you know, tight around these and sort of on top of them. Here they had a different sort of system where these were rails, excuse me, that had insulation and then additional insulation behind it. So again, seeing more mineral wool on projects too, in general. Again, I might skip these, but air barrier, rough opening treatment, window aligned, and then this gets caulked. And then on the inside, they had the taping. And then I think the tape wasn't the first layer of tape, but the second was not installed in this picture yet. So another system we see a lot of is EFIS, and the air barrier goes on the wall first. The installation gets adhered to the wall, but with drainage channels behind it to let water flow behind there and get out at the bottom. And we do see it a lot on some affordable housing projects or areas of the project that maybe the owner's trying to save some money, like the sides or the backyard or something. But I mean, this is a fairly common air barrier and insulation type that's out there. It is, like any system, you have to be mindful of the details, but it's not as complicated as some panel systems where you have all these different connections and you have to work the insulation around all these, supports and that kind of stuff. This is a little bit more straightforward. It's, air barriers on the wall. You have the insulation with the drainage behind it, and then they do the finishes on top. With that, we have seen some projects. So the typical insulation is the EPS insulation, and that's the sort of white styrofoam board that's kind of common. For some higher R value, we have been pushing for or asking for this XPS, which is R5 per inch, so it gives you a little bit more R value. But the feedback has been that it's not as easy to like kind of rasp when they shave the front of it to get it more flat and aligned with the wall. So we have seen projects come back and propose this GPS insulation. So it's slightly better R value, or I think I have the R values called out in a different slide, but it's a better R value than the EPS, but slightly worse than the XPS. So it's a little bit tricky. They, at least on this data sheet, they're saying it's R5, but at 1 inch and 1/16. So that little 16th may make a difference if you're right up against the property line or something like that. But if you have the space, then it shouldn't really be an issue. But this is the installer's feedback, is that this is more so like the EPS, the white sort of styrofoamy cup type, in that it's easier to do the rasping or shaving to when they're doing the base coat and the final coats. Brick. So again, this is CMU, so I might try to go quicker, but the air barrier is on the wall, the rigid insulation is going in. They have their offset shelf angles, so you can see that they're just attached periodically, and this metal piece isn't continuous all the way across. They are also putting insulation in the brackets there to help a little bit with some thermal bridging. But yeah, this is just like a standard kind of brick cavity wall application, and then the boards are pretty tight, but if there's any gaps, they're filling them in with spray foam. More brick, so air barrier on the wall, the insulation, and then the brick in front. And this is sort of in progress. It looks so, not perfect, but they're getting the air barrier on the wall. I think they probably going to do a second coat to really get the full coverage that they need. But yeah, this is liquid applied on a CME wall. And so with any sort of insulation board, it depends what you're using. Is it XPS? Is it mineral wool? The main goal is to make sure it's continuous. So if there are any areas that are have gaps, we're pushing for them to be filled in with some more foam to keep it continuous. These are just some examples of areas where it's short, or extra kind of nicked up, or sort of large areas that are cut out by brick ties, or maybe they just got a little lazy and just tried to shove a little piece in there and it's not really the right size. So you sort of equate this to wearing a sweater that has a bunch of holes in it, right? If your insulation isn't continuous, you're not really keeping yourself too warm, right? So we try to relay this concept during like contractor trainings and initial meetings and stuff, so they can kind of understand the importance of why these little things are important and kind of can add up quickly if a lot of these areas get missed. So mineral wool, we've definitely been seeing more and more of mineral wool. On these rain screen applications, on the even with brick cavity walls, we've been seeing more of it. And it should be easy to line up and hit all the bats pretty easily, but again, if there are little gaps, it depends on which mineral wool you pick and sort of the density, but it is easy to cut little strips or have extra pieces that are laying around and kind of pack them into areas that might be a little bit short or need a little bit of touch up. But it also helps from the perspective that if you're dealing with a CME wall or concrete wall that's kind of not totally straight, which is common, they're kind of wavy. Trying to put a hard, rigid board against it kind of forces you to have the board kind of maybe stick out a little bit or something, whereas the mineral wool can conform a little bit more easily to sort of an irregular wall surface, backup wall. So sort of jumping around here, but air barriers, we have fluid applied. So this would be probably for steel stud application where it depends on the actual product, but you can spray it on, you can roll it, you can trowel it. So there's different ways to do it. We have seen all three applications. The spray is actually pretty good, but you have to have the right equipment and be able to do that. Roll and trowel, you do need, similar to spray, but you also need to make sure you're getting the right thickness, again, with that mill gauge, and not leaving sort of any areas short or not with enough coverage. Sheet applied, so this is fairly straightforward. You have whatever your backup surface is, CMU, Densglass, exterior, wood sheathing for a wood frame project. So typically there's a primer that goes on the wall first, and that's got to sort of tack up a little bit, depending on the manufacturer's timelines there. And then these sheets go on and get rolled with the roller to make sure you're getting the good adhesion. This is an example, kind of a lot going on here. You have a liquid applied from an adjacent wall. You have an infill wall with steel studs. You have some AAC block here to help with thermal mitigation at the parapet and regular seaming above. You have your roof membrane coming up. So I think, they're going to take the sheet membrane and do this whole area and then have these overlaps to the adjoining surfaces and make sure those edges are all sealed. So it's really sort of these transitions that are most important, right? How are you moving from one system or area to another? There's the product where we haven't actually seen this, but this is for a steel stud where it's the air barrier is on the board itself from the factory. And I guess sort of similar to zip, you would just only have to do the seams and the screw heads, but this is a liquid applied flashing, so it's a little, again, bit more robust than some of the issues that come with tape. The manufacturer of this claims that it goes up much quicker because here you have your regular exterior sheathing, and then are you doing fluid applied or are you doing sheet membrane over it? So with this, it's mostly done because the sheets are fully covered, and then you're just doing the detailing at the joints. So I think it's an interesting product. I haven't, and I'm sure they had case studies of where they used it. I just haven't really seen it firsthand on things that we're working on. So I think we're gonna skip some of these. I don't think most people have CMU type projects, but rolling it on, making sure you're getting the proper thickness and coverage, checking it with the mill gauge to make sure you're getting the right thickness. And then the spray is usually the best. You get more sort of fine control and potentially better coverage, but you also need to be careful that you don't get overspray and sort of it running down the wall and kind of slumping. So that's a concern too. So sort of coming together, we have seen this product that's used as an air barrier and an insulation adhesive. So it goes on the wall continuously first, and then the insulation is sort of pushed into it, and it acts as a adhesive to hold the insulation to the wall. So that is also an approach that we've seen projects use. And then this is just, the R value of the insulation board should be stamped. This is probably not a passive house project if they're only using R12, unless they're using, a lot more insulation on the inside. But regardless, that is important. So it's clear what product is being used and the actual R value that's getting installed. I think this is that corner detail from before where this is EFIS and this is the panel, and you can see that the air barriers come up and is mostly wrapping over and kind of meet with the roof. We have the insulation here, and then the EFIS, I think, I'm not sure if it's done yet or not, but it might be, and then it has to kind of come up and meet with the panel. So any of these corners or things like where you have transitions of different materials, could be any backup wall type, making sure how these two membranes are coming together, and then also how the insulation is being continuous. So another little poll question, should be hopefully straightforward, but just kind of getting people's opinions on why continuous insulation is difficult to actually achieve. Penetrations, right? fastening, yeah. Corners, clips, balconies. Yeah, I think I said workmanship in there. I think a lot of times, personally, I think it's because the installers just are always getting rushed, right? Work faster, get it done quicker, and they're just doing the best they can, but maybe just throwing it up as quickly as possible. And um, you're gonna kind of have to see that those gaps are there. So you gotta kind of work with them to make sure they're getting filled in. All right. So this section, I think I'll try to go through a little bit quicker too, so we leave some more time for these other innovative passive house component section. Different roofing types for insulation. We have tapered insulation, so usually some base layers that are flat and then tapered to drains. Like any other insulation, we want to make sure it's nice and tight with no gaps, or any gaps are getting sort of filled in. We have Irma roofs, so that's where the membrane goes down first and then the insulation is on top, and then there's some sort of usually pavers or something that goes as this sort of final coat. The benefit of this is that the roof membrane is protected from UV and temperature, so that definitely helps to have the membrane down here. So we do see more projects kind of looking at it and taking that approach. Similarly, the right size and thickness and gaps are a problem. So kind of want to see it pretty tight, and sometimes they just use pavers to kind of hold it down in place until they get the next layers of the installation. So yeah, this is just showing the next stages where some of these pavers are going on as the final layer of the insulation. Roof integrity testing. So this is just making sure that, and I think all projects actually do this on the Irma roofs, is they flood the roof and they let it sit and see that there's no water leaks. And if there are, they're fixed. And if there aren't, then they know that they can go ahead and install all the insulation on top. It's definitely would be worse to install all of this insulation, find that you have a leak, and now have to take off all these layers to go and find it. Spray foam. So we'd see this fairly commonly as this is actually a floor of a garage, but we also have seen it as roof insulation. Again, like I mentioned before, it's not a bulletproof strategy. The installer does need to be pretty diligent on getting around a lot of these sort of tricky areas to make sure that they're fully sprayed and sealed. And so this is an example from an attic where they had sprayed the ceiling of the sloped attic, and these are these sort of framing members at the side. You can see the foam didn't really make its way totally behind it. And during the blower door test, you can see that these were cold areas that were pulling air. So these are little spots that can get missed, but that goes back to sort of training and talking about details with the installer before to know that these kind of areas are important to make sure that we're getting those as well. This was one of those areas, and this is, us with the can of spray foam, foaming it to see what kind of impacts it would have. And you can see that it's kind of hot now because the foam is warmer, but here it's a little bit not totally maybe adhered to the wall. You can see a little bit of gap. So again, foam isn't a fail-safe option, but can be effective if it's sealing everywhere. But this goes to the installation of the foam itself. So yeah, we can show that there's still some air leakage from that little spot. I think I'm gonna skip that one. So yeah, with foam, just making sure that we're getting the right coverage and thickness, and that it is getting all of these little tricky areas sealed up. So with that, I think we'll kind of transition to this high performance wall guide that we put together. So this is free to download. It's on our website. We put it together as a way to show different strategies for a lot of these thermal mitigating products, and also different wall systems that could be used for achieving passive house level type of wall systems. So I might look at a couple of these. I mean, this is available to look at. So again, this is showing, a standard regular Z-girt up on a wall with some sort of insulation between it, and it shows the thermal efficiency. You can see if you're using a fiberglass girt instead, the efficiency jumps, way higher, or, give some product examples. I think, I'm not sure if it's in this one, but usually for wood, we're usually just seeing, like we saw in that earlier slide, the insulation on the wall and then sort of wood kind of battens on the outside, and it gets screwed through, and that's sort of good enough. It's a cheap solution, and it doesn't require one of these extra products. But there are these other options out there depending on what the final cladding option or selection is. These are a lot of these clip and rail systems. So this was similar to the one that we looked at in some of the photos. There is fiberglass clips. There's other metal ones with plastic behind it. So each has different thermal efficiency properties. And also you can see how these are just spot attachments, so you can keep the insulation more continuous. I think I'll skip this one. This is if you have brick, the impact of different brick ties on the insulation, because these are areas of thermal bridging through insulation. We've seen this one, and also this one. Haven't really seen some of these others, but they are out there. Offset shelf angles, we saw some of that. Or you put a thermal break pad behind the angle at spots, and then you insulate behind there, usually with mineral wool. So that's a strategy to achieve some more continuous insulation that way. Just some of the results of effectiveness. I think we covered most of these already. The ICF insulated concrete form, we've seen some projects use that where the actual formwork is the insulation. So it's insulation on both sides with this sort of plastic that holds it together, and you do put rebar and things in there for structural, but you pour the concrete in and now you have insulation on both sides of your wall. So that's a potential solution. This is some of the AAC block that we've looked at. Okay, I think we'll talk about more of these in the next section, and gonna skip questions. I'll try to get through this last section here and then leave a couple minutes more at the end for more questions. So what we're calling new and innovative passive house components, or things that you can use to mitigate thermal bridging and keep the continuous insulation. So I think this is what someone asked about earlier, the how do you have all these balconies on this project? So you can see that this is the inside, and this is the concrete there, and then this is this shock isocorb, and this is the balcony on the outside. So you can see that this is placed here, obviously before the concrete is poured, and it has the rebar connecting through both ways, and then the concrete's poured on both sides, so that is providing the thermal break, and this is an insulation product that's separating the two spaces. So this is a little bit clearer. You can see that it's got, this is the insulation and the rebar, and then, it gets poured on both sides, and that's how you're separating it. Here, this is after, you can still kind of see it in there. It might get covered with some extra, mortar or whatever, but this is showing like you can still see that it was installed. And then some of them too, you can kind of see little remnants of it at the bottom. So at least for verification, we usually try to come and see it at this stage so we know it's actually there, it's the right product. There's different series of this isocorp, and making sure that it's actually installed. This one is at a little parapet, so you can see that they're calling it out here, and then that parapet would go on top of it, and that's how they're keeping this sort of wrap of insulation. And this is, you can see it, the label on it, a little bit jagged, but it is there. This is the insulation, and then this is all of them in place. This was one of those various, clip and rail systems. This was this little hat channel that came with insulation in it already from the factory, which definitely helps. And then, so that goes on the wall, and then the other insulation layers, come up and are on top of this. So, this was a custom sort of solution from that particular panel manufacturer. They're like, oh, well, we could send you these with insulation in them already. So that definitely helped. These are the sort of thermally improved brick tie anchors. So, this is from the manufacturer's website, but it's telling you the conductivity of the actual product itself, and how they compare to sort of more traditional brick tie products. These are some of these additional rail and clip systems. I think we saw this photo before, but this is, and when I say plastic, it's, pretty heavy duty, like I can just break it with my hand type of plastic. Like these are supporting panels, so it is an engineered system. So these go on, and then the rails get attached. The insulation's all continuous around it, and then the panels get, attached to these clip and rail systems. Another product we see a lot is this Armatherm. So it's a high compressive strength insulation material, and we typically see it under steel or other sort of high load areas that you can't really get normal insulation around. So here we have, you know, a column, and then we have the Armatherm underneath it as serving as a thermal break there. And sort of in practice, this would be, this is a support for a rooftop ERV that's going to sit on there. And you can see that they've built it up and put a bunch of the Armatherm blocks to get the thickness, and that's going to be, you know, the same height as the roof insulation thickness. So they usually do, depends on how they're doing the roof or what the system is, but do the flashing around it and then bring the other boards tight so you can have these areas of insulation sort of meet and be continuous. And so the thing about the Armatherm is you can buy it in big sheets and then kind of cut it and use it as needed. So here you can see that they've cut their different blocks and they're starting to pre-drill them. This is for I think a glass sort of railing system that they were using. So getting those installed before the supports go in, and then doing the roofing around it. This is that smart fiberglass. So anywhere you might need a metal piece, you know, you can hopefully maybe do it in fiberglass instead. That could be an option. We talked about the EPS and the GPS a little bit earlier, but the GPS is not as good as the XPS, but pretty close, and it is better than the EPS. So this could be an option if you do have EFIS on a project and you're trying to get a little bit more R value. This could be a way to go to get that. All right, so of those products or any others, just polling the audience to see if have they seen any of these, or are they familiar with any of these sort of products that are out there. Yes. So the clips, the ICF, GPS, that's interesting. Some SIPs, okay. Yeah, the clips, there's a whole bunch of different options on these various clip systems. So all right, some Armatherm out there. Comfort bat. All right, that's pretty good. So we're kind of getting to the end here. Just kind of asking for general feedback, any final thoughts or takeaways from the presentation today. Anything you kind of want to put out there would be the spot to do it. Refresher, good. Organized, thank you. Yeah, mock-ups, definitely push for those pretty heavily. Some of the chat questions. Hopefully some of the details we showed were clear and can be replicated. All right, so I think that's pretty good on some feedback there. And so we'll kind of wrap up with any final questions that have kind of come in the chat or anything else anyone wants to sort of bring up.
Okay. Are there benefits to AeroSeal type products being used in the field in lieu of the more traditional sealing methods?
Yeah, they're probably talking about aero barrier, which is the blow-in sealant for air sealing apartments or spaces of a building. We have seen aero barrier used, and it is a good product in getting leakage down further, but it isn't going to replace a traditional air barrier system. The aero barrier that is blown in can only seal holes of a certain size. It's essentially, it's similar to the AeroSeal for the ductwork, where it kind of finds gaps and cracks and builds up and seals. I know that I think the AeroSeal for the ducts is like 1/2 inch size. So, you know, if you have areas beyond that are you know, open, that the air barrier isn't going to do it. You know, it's definitely a good solution if you're sort of close and you need an extra push to get your final tightness, or you know, if you want to just sort of get that extra amount that would be a little bit harder to get from manual sealing. It's definitely, I think, a good approach, and you know, again, we have seen it. But to say that it can replace or be used in lieu of some of these other systems, I think it's not really there, because it can't handle big holes. So it does have its place, but I think it's sort of more supplementary than being the main sealing system.
What happens to the mock-up materials after they serve their purpose? Is there less waste if you could do it on site?
A lot of times the window that's used in the mock-up is used somewhere on the project site. So, you know, you're not throwing out a window. If you are doing the mock-up on the building, right, there's no waste there, it's on the building itself. But yeah, I think the rest of the materials probably get scrapped, but hopefully, you know, a lot of the projects are doing other programs too, like enterprise green communities or LEED, so they do have requirements for sort of recycling of materials if applicable. You know, maybe an air barrier on a brick isn't, or I don't know, CMU isn't gonna really work, but yeah, I mean, fortunately, the construction industry is fairly wasteful in general, but.
Do you see a lot of IRMA roofs?
On our, you know, mid to larger projects, yeah, we do have a good amount of IRMA roofs. The insulation or the waterproofing layer goes down first, the insulation on top, and then they usually have pavers. You know, sometimes the roofs are tenant accessible spaces for, you know, recreation or something like that. Other times they're off limits, but we do see a decent amount of IRMA roofs. Obviously, if it's a flat roof type of system, I would say it's kind of split. You know, we see traditional tapered insulation roofs as well. Again, for flat roof scenarios.
Okay, and that's it.
Okay. So just a quick reminder, you know, we do have a couple more workshops upcoming. Workshop 2 will be a little bit deeper of a dive onto some of the sort of building envelope trades and that kind of thing. And we do have some more, I think in that one, we start some videos of showing applications of the air barriers and how these things actually get installed to sort of take those directions and put them to life. And then workshop 3 is HVAC and plumbing, and then 4 is QA, QC. So how we're sort of checking and making sure that everything is going smoothly and getting installed as it should. So I think, did Anna want to maybe jump in here for something?
Yeah, thanks, Mike. That was a really great intro presentation to passive house building envelopes. For everyone in the audience, make sure you are registered for the rest of the workshop series. Yeah, the next one is scheduled for next Friday, the 19th, and the other 2 are taking place in April. Also a reminder, just to be on the lookout for our emails, and there will be a survey link included, and we would greatly appreciate your feedback and any comments on these workshops that we're holding. That's it for me.
Okay. So there's my contact info if anyone's has any burning questions. And yeah, thanks for listening in today, and hopefully it was useful, and we'll see you soon.